right. Well, thanks for coming, everyone. I see there's a few of you out there on Facebook watching as well. The Aurora Public Library District is pleased to welcome back Michelle Nichols, the astro educator. She has done programs for us before, and it's always been a wonderful time. Today, she is going to talk to us about astronomy using our eyes. So what we can see in the night sky simply by going out in the yard and looking with our own eyes. So go ahead, Michelle, take it away.
All right, thank you so much, Megan. Hi, everybody. My name is Michelle. I work at the Adler Planetarium in Chicago, but the Adler is closed to the public right now, so we're all working from home. So welcome to my house. And I live about 5 minutes from the Eola branch of the Aurora Public Library, so it's really great to be able to do this program for you guys. Do me a favor, everybody who's in Zoom, if you don't mind, if you could stop your videos. You'll be able to turn back on later on, but to make it a little easier for folks and to make it a little easier for the recording, if you could just stop your videos, that would be great. Thank you so much for doing that. And then periodically, I will stop during the program and take questions. And so if you're in Zoom, then you can just put your questions in the chat. And Megan, give me a thumbs up if you don't mind breaking in every now and then and throwing me the questions from Facebook. Excellent. So those of you on Facebook, if you have questions, just put them into Facebook and Megan will relay them to me since I can't see them, and we will go from there. So we're going to talk about what is in the current night sky. We're going to talk about some lunar eclipses that are coming up in the next couple years. We're going to talk about some solar eclipses that are coming up in the next few years, what meteor showers to look for, and stuff like that. None of this will require a telescope, which is great. You just need your eyeballs and a reasonably clear sky. So I checked the weather. Of course, right now it is cloudy, but I have some resources that I'm going to give you that you'll be able to use after tonight to be able to figure out what's in your night sky. So it's a resource that we've been using at the Adler, and so it is something that I want to share with you. It is completely free. It is online, and it's really simple to use. So why don't we get started? I'm going to share my screen. So give me just a second. There we go. All right. So like I said, I call this astronomy using your eyes because even though we hear all about telescopes and binoculars and that sort of thing, sometimes we just want to go outside and look up. Sometimes you just want to go in your backyard and you want to know what you're looking at. So I want to give you some things that you can look for in the night sky. And first thing we have to talk about, though, is a question that we get a lot. Where should I go to actually observe the sky? The great thing is we can all just go in our backyards, a nearby park, someplace nearby. And the sky isn't, well, shall we say, terrible. It's okay. Out here, we're a little farther away from the city of Chicago, but we want to consider the lights whenever we're thinking about where we might want to go observe. And light pollution is the name that we give to the phenomenon where you've got lights that are shining up into the sky, not down here where we need them, but the light shines up into the sky and reflects off of water vapor and pollution, anything else that happens to be up there in the air. And the light shines back down into your eyes and essentially makes the sky seem a lot brighter than it normally would be if there were no lights. This map is available online. It's a worldwide map of light pollution, and it can help you if you might want to think about traveling somewhere to be able to see the sky. Now, of course, in this time right now, travel safely and carefully, but if you are going somewhere, or even if you want to see what the light pollution situation is for your particular area, lightpollutionmap.info is a great resource. I've zoomed in on the map to show the light pollution in our area. Of course, Aurora is west of Chicago, and as you can see, we are in the thick of some of the worst light pollution that you can possibly have. It is a little worse in the city itself, but it isn't that light pollution stops if you've got an area that has no lights sitting right next to an area that is well lit. And the reason for that is the light goes up and it goes out. And so we've got this dome of light above us. And so even though we're not next to Chicago, there's still the suburbs, we've got the city itself, and that light goes up and out, and it makes the sky seem really, really bright. If you take a look, there is a spot, I think you can see my cursor, there is a spot right in here, right where it says Naperville, the NAP part of Naperville. Those of us who live in the general vicinity know what exactly is over there. We have the mall and all the car dealerships, and that actually makes a noticeable brightening effect on the sky. So even something like that can actually have an effect on our skies. Now, when you start to look into the areas to the west, you start to see oranges and yellows. It's a little bit darker out there. When you get into green and blue and purple and gray or black on the map, you actually can get into some pretty dark skies. Now, most of Illinois does suffer from a halfway decent amount of light pollution, but again, I get asked a lot, where can I go to see a fairly dark sky? The first place I might recommend is the Green River State Wildlife Area. It is a couple hours, about an hour and a half, something like that, away from here, and from Aurora, the Aurora Naperville area. And the light pollution is not terrible out there. If you take a look, I've got the pin here in the light pollution map. It's in the blue. There are some light areas. The town of Dixon is nearby, and we've got a few areas around there that are a little bit lit up. But for the most part, this is one of the darker areas that you're going to find in the state. I do recommend if anybody wants to go out there, call ahead and make sure with the park ranger that any areas aren't being taken up by hunters. They do have hunting season out there, and we're coming up on deer season, and I'm sure there are other seasons of hunting happening right now. But just call ahead and make sure that that you can actually stay there when it's dark, and that there are spaces to stay, because hunters might be taking up those spaces as well. Another place is the Middle Fork River Forest Preserve, and this is designated as a dark sky park by the International Dark Sky Association. And so this is a little bit northeast of Champaign. And again, if we take a look at where the pin is, it's not terrible. It's kind of on the green-blue area of the light pollution. And so again, not bad. There are other areas in western Illinois that are even slightly darker, but this place is not too far away from here. Champaign is maybe a 2-hour drive from here. Again, check on the website, call ahead, make sure it's good and safe to be able to stay there. They do have camping, and so you can check and see what the requirements are to be able to camp there. So during the COVID lockdown times, it was a little fluid as to whether or not you could actually stay there, but I think they've got it open for camping now. So anyway, you've got light pollution in our area, but it's not hopeless. The reason I say that is even with the light pollution, there are still plenty of things that we can see. If you go outside, what I want you to do, though, is not take the brightest flashlight that you have to be able to, say, light up your phone screen or light up a book or something that you might take out with you. I want you to take a red or orange light. And people ask me, where can I get a red or an orange light? And the answer is you can make one. You can take a flashlight, and usually around the holidays, they have that colored saran wrap. Or colored plastic wrap. You can put a few sheets of that over your flashlight and make your flashlight a red or an orange color. The reason for that is our eyes are not as sensitive to red. And when you're outside in the dark and you suddenly shine a bright white light, you're going to lose your night vision. So over about 20-30 minutes, your eyes get fully adjusted to the dark. Your pupils are all the way open. Your eyes have a certain chemical in them that is sensitive to dark and seeing faint amounts of light in the dark. If you shine a bright white light, you're going to lose that night vision and you're going to have to wait another 20 or 30 minutes to be able to then fully see what's going on around you. Now in our light polluted areas, it's not quite as necessary because it doesn't get fully dark around here. But if you're going to Green River, if you're going to Middle Fork, if you're going to someplace really dark, that is really important. So red or orange are colors that our eyes are not as sensitive to, but also the brightness of the light matters. Don't get the absolute brightest red light you can find. That also can mess up your night vision. So you want just a moderately bright light, red or orange in color, and you're good to go. All right. You can also sometimes with some phone apps, they may have a night vision feature that cuts down on the blue light, or you might have the dark feature on your phone that also cuts down on the blue light that your phone emits. That is also a good thing to do. And even some night sky apps have a night sky feature which turns the whole screen red. And so that also will help your night vision. I'll show you an example of that in just a sec. Now, when to go observe, you might want to consider the moon. If the moon is what you want to look for, then you want to view something like a waxing crescent moon. I'll explain that in a sec. You might want to view a first quarter moon. You might want to view a waxing gibbous moon. Again, I'll explain it. But also, if you want a really dark sky, you might want to pick a time when the moon isn't out when you're going to be out. And so I'm going to show you a resource in just a sec that you can use to help you see what's up in the night sky and is the moon going to be out when you're going to be out, and if so, what phase is it? So you'll see that in just a second. But one great time to go out and not see the moon is new moon. And that's coming up in 2 days, October 16th. So new moon means no moon. It means the moon is in the same part of the sky as the sun. The sun is much brighter than the moon. We can't see it. And so and also it's the shadowed side of the moon that is facing us at that point. So new moon means no moon, and it means the darkest sky you can get, especially if then you're under an actual dark sky. Now, if you want to see a moon when it looks pretty good, you might want to see this. This is called a gibbous moon. And gibbous is, it means humpbacked, or it kind of looks like football shaped, right? And so this moon is pretty bright. Again, if the moon is what you want to see, seeing it like this is pretty good. If the moon is what you don't want to see, then you want to pick a night when you don't see the moon this big. Or even full moon. Full moon is when the moon is at its brightest, when you've got the sun goes down, the moon comes up, and so the moon is up all night long and interfering with your dark sky all night long. And so anything related to gibbous, when the moon is more than half, less than full, if you want a dark sky, stay away from that. If you want to actually view the moon, that's a good time to see it, okay? All right, we're gonna check out tonight's sky. So I'm gonna stop sharing this for just a second. And, all right, Megan, any questions before I move on to show the next part?
Not yet. Just a couple people saying hello. They're glad they could be
Hello.
here.
Oh, excellent. I'm glad that they could be here too. All right, so I'm going to share a different resource. All right, those of you who are watching at home, well, actually everybody's watching at home. If you're watching on a resource that allows you to keep watching, but you can bring up a web page, you might want to bring this up. This is called Stellarium, STELLARIUM.org. If you bring up that web page, actually I can bring up the actual web page. Here's the web page, and up here to the upper right it says Stellarium Web, and you'll want to click that. There is a downloadable app version of this. There's a for your phone. There is a downloadable version of this for your desktop or laptop. The version for your phone I think costs $3. The version for your desktop or laptop is free, and the version just online is free. So I'm clicking that Stellarium Web, and I'm going to allow it to detect where I am, and I'm going to use this little hamburger menu here to get rid of that menu on the side. And so it has detected that I am in Aurora, and probably several of you watching are too. And so it is showing me what the sky looks like tonight. I'm going to adjust this for tomorrow night because it's cloudy out right now. So I want to show you what the sky looks like tomorrow night, which will basically be what it looks like tonight. But I wanted to show you how to do this. So over here in the lower right is a time clock. It's a 24-hour clock, like a military time. So if you want to see what the actual time is, take that time, subtract 12, and add PM. So in this case, it is set for 1920, which is 7:20. So we're going to click that, and I'm going to stop the clock from moving forward. I don't need it to keep churning. And then I'm going to move it to tomorrow. You can see this, the sky moved just a little bit, and I'm going to move it to an hour later, just so it's good and dark. All right. This is also telling you it's where the little dot is in the little graph on the bottom when you're actually going to experience dark hours. Okay, so then you can change this for any year, any date, any time, but we've got it set for 8:20 p.m. tomorrow night. So I'm going to click in the middle of the screen and it'll get rid of that. So I can also click and drag and move around, and I can see what is up in the sky right now. Now, the one thing that you can't do with this online version that you can do with, I think with the phone version, although I've never used the phone version, I've only used the desktop version. One thing you can definitely do with the desktop version is adjust the amount of stars that you see based on the light pollution that you're in. Stellarium connects with that light pollution database, and it will show you a realistic number of stars in the sky there on the screen based on where it detects you to be, and so then it kind of knows what your light pollution situation is. I can't do that with this one, so you're going to see a lot more stars on the screen than you're going to see in the real sky, and that's probably not surprising to any of us who've been outside to look up. You go, wait a minute, I don't see this many stars, and that's true, but that's a limitation of the online version. Next, I can turn on constellations if I want to. And you can take a look at all those drawings and go, wow, those constellations don't look anything like what they're supposed to be. And you're right, most of them don't. So we can turn those off if we want to. I can turn on artwork if I really want to. And we can see what the constellations are supposed to be. Again, they don't really look like what they're supposed to be, so that's okay. I'm going to turn that off. We can turn on a few grids. We don't really need them right now. Night mode is what I told you about. If you're out in the dark and you want to take your computer or something with you and you want to adjust this so it won't mess up your night vision, you can turn it to night mode. But I'm going to turn that off. And so anyway, what do we have up right now? What is up in our early fall sky? You probably heard about Mars over the last few weeks. So we're going to turn to the east. And I'm going to turn the constellations back on. There we go. And so Mars is this dot right here. Mars will not be that big in the sky. What they do is they make a bigger circle on the screen for something that's brighter. And so something that's dimmer is a smaller circle. This does not refer to the size that that object is in the sky. Mars will never be this big in the real sky, okay? So to the east, we've got Mars, and it's pretty much the brightest thing to the east. You have no trouble seeing it. Those of you who have wondered, what is that bright orange thing to the east? That's Mars. And then we have a few stars over in this direction. This constellation right here is called Auriga, and it is a charioteer whose chariot is being pulled by goats. It's okay if you don't see a chariot being pulled by goats, but I want to bring up that this star right here is called Capella, and it's kind of a yellow color in the sky. You can see that. It's one of the brighter stars that's over in that direction. So if you see that star, that is the star called Capella. Then we're going to move over to the south. So if you are facing east and you want to go to the south, you want to go 90 degrees to your right, and you're going to be facing south. Again, we've got two objects that are fairly bright. The right-hand one is brighter than the left-hand one. I'm going to zoom in a little bit, and we have identified those two as Jupiter and Saturn. Now, if you're wondering if you're viewing a star or a planet, a good rule of thumb that is the case most of the time is Stars twinkle, planets don't. And it's not any inherent quality of a planet necessarily that makes stars twinkle and planets don't. There's two reasons. Number one, you're looking through a decent amount of air, and planets are a lot closer to us than those distant stars are. So even though the stars are bigger, they're a lot farther away. And the beam of light from those stars is really thin. The beam of light from the planets is a little bit bigger, and so the beam of light is not affected as much by the air that the light has to travel through. So the more turbulent the air, the different temperatures and all that, you're going to get more twinkling. You may see a little bit with the planets, but not really, not a lot. You may see some when they're down closer to the horizon. The other thing is that planets are disks, little teeny tiny disks. You won't see that in the sky with just your eyes. You would with a telescope. But they're little teeny tiny disks as opposed to the literal pinpoints that stars are. Again, stars are big, but they're really distant, so that's why they are just teeny tiny pinpoints. And no matter what size telescope you use to look at them, they're always going to look like little pinpoints, whereas the planets are going to appear like disks and then slightly bigger disks if you magnify them a little bit. We do have a constellation that you probably have heard of. This is called Sagittarius. He is an archer, so let me turn on the artwork. There we go. He's a half man, half horse carrying a bow and arrow. And if you don't see the half man, half horse carrying a bow and arrow, you probably see a teapot right here. So those teapot stars are the ones that you'll probably see. So here's the handle, there's the base, there's the spout, and there's the lid. So if you don't see half man, half horse carrying a bow and arrow, don't worry. I don't either. And then we have other constellations that you probably have heard of: Capricorn, Aquarius, Pisces. All right, getting into Aries and Taurus. These will sound familiar. These are the zodiac constellations. And the reason for those zodiac constellations is the ancients, they were avid sky observers, paid attention to the sky. They noticed that these objects, certain objects, only stayed within this band of constellations in the sky, and they thought those to be important. And so they marked out that part of the sky. Different cultures marked it off in different ways. There were over time, there were some cultures that had identified 12 different constellations, and those are the 12 constellations of the zodiac. Those aren't the only constellations. Those aren't the only cultures that did that. Those aren't the only, it isn't just 12 all over the world. It is the principal constellations that we use. A lot of them came down from the Greeks, the Romans, the Babylonians, and so that's kind of why we focus on those. But there are hundreds and hundreds and hundreds of cultures all over the world that had their own connections to the sky. There is no one right way to draw the sky. So if you don't see Pisces as two fish being tied together at the tails, again, don't worry. I don't either. It's just, they're just kind of a big triangle. And that is totally fine if you want to call it that. Looking up at some of the other constellations that we have, up above this zodiac, this group of constellations here, we do have a square right here. So again, if we face south, a little bit east of south, and we look up, we're going to see close to overhead, you're going to see this big square. This is the constellation of Pegasus, the flying horse. And here is Pegasus's head and body, only the front half for some reason, and front legs and wings. And so here is Pegasus. No one ever draws the back half of Pegasus, only the front half. Don't ask me why. I have no idea. But that's usually how it's depicted. All right, so you'll see Pegasus in the fall sky fairly easily. So it's going to be a very recognizable large square of stars in the sky. All right, so we've got our zodiac constellations. We also call it the ecliptic in astronomy. We've got 3 planets that are out in the sky. We've got Pegasus the flying horse, and we have also, if you go out under a dark sky, you may see the Milky Way. So the Milky Way is this cloudy band of stars across the sky. And here in Stellarium, you can see that as this band right here. Now here in Aurora, we will not see the uh, the Milky Way. Um, we just have too much light pollution. I could almost convince myself that I saw it in the spring, but the air conditions were just right, the dark conditions were just right, and I really had to kind of convince myself that I was seeing it, and I probably wasn't. But going up from Sagittarius up through this constellation right here, and this one right here, this is called Cygnus the Swan, also called the Northern Cross. And whoops, sorry. I'm trying to go slowly for those of you on Facebook so I don't make everybody completely ill watching this. We've got this W-shaped constellation. This is Cassiopeia the Queen. And then coming down through Perseus the Hero and back to Auriga, which is where I started. So you can trace out where the Milky Way is supposed to be. You may not see it unless you're under one of those really dark skies, right? But I bet you some of you have actually seen it. Finally, if we go over to the north, we have a group of stars here that you probably have seen before. This is the Big Dipper. The Big Dipper is part of a much larger group of stars called Ursa Major, the Great Bear. If you take the two stars, well, here's the handle of the Dipper, here's the bowl. If you take the two stars farthest from the handle and you draw a line, you're going to run into this star right here. It's called Polaris, the North Star. I'll zoom in a little bit. There's the name. And so Polaris is not the brightest star in the sky by far. There's about 40 other stars that are brighter than Polaris. The reason it's important is our Earth's North Pole points almost directly at it. And so as we go through the hours, you'll see everything turning around Polaris. And you'll see this night after night, day after day, month after month, year after year. And so these constellations here never set below the horizon. So the Big Dipper will, at least at our latitude, will not set. And so you'll always see it at some point. It might be pretty low, it might be fairly high, but this group of stars we call circumpolar. They circle Polaris, circumpolar. And so they all circle around Polaris, the North Star. And then I usually get asked by someone, is there a South Star? And the answer is no. The Earth's South Pole does not happen to point to a part of the sky where there happens to be a star. We just happen to live in a time period where right now there is a star in that direction. But a few thousand years from now, the Earth's pole is going to point in a slightly different direction. And so it isn't always going to be Polaris that will be our North Star. Pretty cool. All right. So that is Stellarium. I hope that is something that is useful to you. I wanted to point out one more thing coming up in the morning. So this is now set for 3 o'clock tomorrow morning, or sorry, it's the day after, but 3 o'clock tomorrow morning will work too. You can see Orion, which is a wintertime constellation, Canis Major, which is his hunting dog. Here's the belt of Orion right here. And these three stars point toward the brightest star in our nighttime sky. This is called Sirius, also called the dog star. But I'm going to go forward in time just a little bit and move to the east, and we can see a very bright planet over here. That's the planet Venus. So if you've been up in the morning before sunrise and you've wondered what is that extraordinarily bright thing to the east, that is the planet Venus. So you can see 4 of our 5 naked eye visible planets right now. And the only reason you can't see Mercury is it's too close to the sun right now. We can't really see it. So it's okay. It's not worth seeing anyway, in my opinion. So, all right. So there you go. There is Stellarium. So we have a question. What is the most visible constellation? That's a great question because that depends on how bright the stars are, right? And so in my opinion, you'll find some of the brightest stars, not the brightest star, but some of the brightest stars in a somewhat recognizable shape, Orion is, in my opinion, one of the easier constellations to find, especially in the late fall, winter, and early spring, because the stars are fairly bright. The shape is easy to pick out. He looks like a sideways bow tie, right? And basically every continent on Earth can see Orion, or at least part of it. So Orion, to me, is the most visible constellation in our nighttime sky. So it's up in the morning right now, and as we go toward winter, it'll be visible earlier and earlier each night. So there we go. Megan, any questions on Facebook before I go on?
No, I see people watching, but I don't have any questions yet.
All right, no worries. Those of you on Facebook, just to remind you, if you have questions, throw them into the Facebook post for this session. I'd be happy to answer your questions. So we will go on. All right, I'm going to go back to sharing my screen, so give me just a second. There we go. Okay, I took a picture, a couple pictures a few months ago when the comet was visible in the sky. But I wanted to not show you the comet in this picture, I wanted to show you the planets to give you a sense of what to look for. So I took this picture, some of you may recognize this location. This is the Walmart edge of Springbrook Prairie Forest Preserve in Naperville. And so this bright dot right here, this is Venus. So it will appear like a non-twinkling, really bright dot in the sky. So this was right before sunrise. And then this is Saturn, this is Jupiter, and this looks like the sun, but it's not. This is the moon. It was close to full when I took this picture, but I had to overexpose the moon in order to get Jupiter and Saturn in the picture. But I wanted to point this out because it's showing you how bright Jupiter is compared to Saturn. Those two planets are similar in size. Saturn's a little smaller, but Saturn's twice as far away. So it will appear dimmer. So Jupiter's about 500 million miles away, give or take. Saturn is about 1 billion miles away, give or take. So this is not, it isn't going to affect the brightness too much about the size difference. It's really more the distance that can affect the brightness a lot here. So, all right. Everyone wants to know about eclipses. So I'm going to tell you about some eclipses to look out for. And so what an eclipse is, now I hate this drawing. I apologize. I hate this drawing. But the problem is you can't easily depict what I want on one single screen. So this is really difficult to do. This is not to scale. All right. But a lunar eclipse, it happens when the moon passes through the shadow cast by the Earth into space. Sun falls on the Earth. Earth casts a shadow, just like sunlight falls on you. You cast a shadow behind you. Sunlight falls on the Earth. Earth casts a shadow behind Earth. And sometimes, occasionally, about once or twice a year, the moon passes through that shadow cast by the Earth, and that is a lunar eclipse. Now, this is not to scale. We would need, and again, I think you can see my cursor, we would need the moon to be way back here on this shadow to really be a depiction of more like reality. But in order to actually make this a fair drawing, they put it a lot closer, but it's not this close for sure, right? But what you can see also is we've got two parts of the moon's shadow. The outer lighter part called the penumbra and the darker inner part called the umbra. And so that can affect the visibility of lunar eclipses. Now, a penumbral lunar eclipse, I'll go back, means the moon is only going to hit a little tiny bit of that lighter shadow. So this set of pictures is when the moon passes through the lighter part of the shadow. And this is what I'm going to tell you. Coming up in November is one of these eclipses. It happens at whatever o'clock in the morning. I think I've still got it in my slides here. We'll get to it. I'm here to tell you, no matter what you might hear on the news, no matter if someone says there's a lunar eclipse in November, I want you to sleep in. ignore this one because take a look. Do you sort of see that little bit of shading there? That's it. That's all you're going to get. That little bit of shading change, you may not even see the difference to your eyes. So not worth getting up for in the middle of the night. Here is a slightly deeper penumbral lunar eclipse. Again, illustrating don't get up in the middle of the night for one of these eclipses. If you happen to be up, great, go out and take a look. But if you hear about one of these eclipses, penumbral lunar eclipse, you can ignore it with my permission because I will be sleeping in. All right. So then we've got a partial lunar eclipse, and what that means is the moon, this is full moon only, the moon passes through a little bit of the darker part of the shadow, and you can see what sort of looks like a bite being taken out of the moon. And so that you can see with your eyes, that looks cool. If one of these is happening, I do want you to get up and or stay up or get up early in order to see one of these. Then we've got a total lunar eclipse, and that is when the moon fully is within the darkest part of the Earth's shadow. Okay, so that's when the moon's color might appear gray or brown or red or orange. All right, so we don't know what color we're going to get till we see it, but we can see those colors. And there is a scale called the Danjon scale, and so the scale basically is referring to what color we get when we see a total lunar eclipse. Okay, and I think I saw a question pop up, so let me see if I can bring that up. No, I can't. Can you, Megan, can you see the question in the chat? Whoops.
Yeah, it says how many eclipses are there this year?
For lunar eclipses, we had one, a penumbral lunar eclipse on July 4th, on the evening of July 4th. And if you were out watching fireworks, because everybody was shooting off fireworks on July 4th. We had them going off in our neighborhood nonstop for 3 solid hours. We didn't. We just went outside and listened to it all. But there was a penumbral lunar eclipse that night. And if you're thinking, I don't remember an eclipse exactly because it really didn't cause the moon's color to change all that much. The next one is in November. So you get on average about 2 of these lunar eclipses a year, not or 2 lunar eclipses total. Not all of them are visible here. Earth is round. Sometimes we happen to be pointing in the direction of the moon when the eclipse is happening. Sometimes we're not. So on average, it's a couple times a year, right? So November 30th, this is the one you can ignore. If you hear about this on the news, sleep in. So it starts at about 1:32 in the morning and ends a few hours later. Forget it. Don't worry about it. May 26, 2021, we will see a partial lunar eclipse. And this one starts at 3:47 in the morning. We're not going to see the whole thing. It is a total lunar eclipse, but this one, the moon will set in the west before it is fully within the Earth's shadow. So we won't get to see the whole thing. People out to the west, like we're talking like Mountain Time Zone, Pacific Time Zone, they'll see a lot more of it than we will. I think Hawaii might get the best view of this one. November 19th of 2021, we get an almost total lunar eclipse. The moon, we'll see the whole thing, but the moon won't fully be within the darkest part of the shadow. Just a little bit of it, a little sliver of it will still be in that lighter part of the shadow. I have a feeling this one's going to look really cool. So, so this one is worth getting up for or staying up for. I just hope it's clear. It's November after all. And then May 15th of 2022. And again, if you miss these times, just rewind the video. You'll be able to get this. May 15, 2022, starting at 8:32 p.m. So yay, not at whatever o'clock in the morning. We have the moon starting to go within the light part of the shadow. If we go forward in time, then about an hour or something like that later, it goes into the darkest part of the shadow. And then it is fully within the dark part of the shadow, goes across, and then goes out. So this whole entire process takes a few hours. So starting at 8:32 in the morning is when the PM is when the penumbral part starts, and then the darker part starts like about an hour-ish after that. So that one will be good. Put this on your calendar, May 15th, 2022, right? Now, solar eclipses, again, if we get 1 or 2 lunar eclipses a year, you also can get 1 or 2 solar eclipses a year. They're usually paired up about 2 weeks apart, because if the moon is lined up correctly to go within the Earth shadow, it's lined up correctly to line up with the sun in the sky. So we have a partial solar eclipse when the moon partly covers the sun. You got a total solar eclipse when the moon completely covers the sun. And then there's kind of a slight hybrid version. I'll show you that in a sec. So June 10th of next year at sunrise is what the sun is going to look like here. So the sun is gonna rise partly eclipsed by the moon. The total amount of time for this eclipse is about 20 minutes. That's all we're gonna get. It's gonna rise eclipsed partly, and it is already on its way away from the sun at that point. So we will literally only get maybe 20 minutes of a solar eclipse. So if you want to see this one, you got to get up at sunrise with those solar viewing glasses that you might have left over from 2017, or you just spend the dollar and get a new pair, which is what I highly recommend. Just get a new pair of those. Just don't recycle them from 2017. Wear those, and if you have a clear view down to the horizon, then you should be able to see this eclipse, right? Just check and make sure you've got a space that has a clear view down to the horizon. That can be a little tough to find in our area. But one place that you could try is the Walmart parking lot at 75th and Route 59. They have a somewhat decent view over there to the northeast, so you may want to try that. Just check with Walmart that it's cool. Well, they're open 24 hours. They'll be there. October 14th of 2023, starting at 10:37 in the morning, we are going to have about a total of about 43% of the sun covered by the moon in this area. And so again, it'll take a little while for the moon to march its way across, but this is what we'll see from this area. But if you happen to be in this path where it's marked off in blue, if you happen to be anywhere in that path on that date at the right time, you're going to see this kind of an eclipse. This is called an annular eclipse, A-N-N-U-L-A-R, annular eclipse. The word annulus means ring, as in there's a ring of sun left around the moon because the moon doesn't completely cover the sun at that point. So we won't see this version of it. We will see when the moon is partly covering the sun. But if you're within that path at the right time, you're going to see this kind of an eclipse, either with the moon centered on the sun, or it might be off to one side, all right, one side or the other, depending on where you are in that path. Still looks pretty cool. I saw one of these in 1994 down in Champaign. Still a cool thing to see, but you still need those glasses, those solar viewing glasses to see it. This is not safe to look at directly with your eyes. Only when the moon 100% covers the sun, that is safe to look at with your eyes. That is going to happen on April 8th of 2024. We will not see totality, as in the moon totally covering the sun in this area. It's going to be 94% covered. I'll show you what that looks like in a second. But notice, if you are anywhere within this path, marked off in blue, you will see the moon totally covering the sun at some point during that eclipse. It's going to last about 4 minutes that the moon, at most, that the moon will totally cover the sun. In our area, it's going to be in the afternoon when this happens. So 1751 is 17 minus 12 is, sorry, 17 minus, no, that's universal time. Sorry, 17 minus 5 is 12:51. So this is going to start at 12:51 in the afternoon. And again, we aren't going to see totality here. This is the most that we're going to see, 94% of the sun covered. You will need the glasses. Plan now. Get those glasses if you can. Don't recycle them from 2017. Spend the dollar and get the new ones. And get them from a reputable solar eclipse glasses manufacturer, not from the cheapest place you can find them, not from big giant online retailers. We all know which one I'm talking about here. They're great for stuff bad for glasses. So anyway,
Do you have a
uh,
recommendation for where to get the
yes,
glasses?
I personally, my own personal recommendation is Rainbow Symphony. That's where the Adler, that's where we got our glasses in 2017. And ours were up to spec, no problems. So I recommend getting them directly from the company. And the other, here's the pro tip. They always have glasses left over from other eclipses in other parts of the world. Like they might get a print run of them and they may have some kind of picture on them or something. And then once that eclipse is over, now they're stuck with all these glasses. Then they sell them for cheap. Go and buy as many of those print run over ones or the ones that are left over from the eclipse just prior, and you will have all the glasses you want, and they are 100% safe. They just won't say whatever eclipse it is that you're watching. It's the prior eclipse or something like that. So pro tip, there were people who did that and bought a lot of glasses for a very inexpensive amount of money. So Rainbow Symphony, I like them. But this is what totality can look like. So this is somebody else's picture of totality. When the moon totally covers the sun, you can take those glasses off and you can see this. So once you've seen one of these, you're going to want to see another one. I guarantee it. So, all right. Any other questions before I move on to meteor showers?
Nope, I don't see any.
Excellent. I must be answering every question ever, which is great. All right. This is actually my picture from the Perseid meteor shower in August. So you can see this streak here in the sky. I literally took 1,000 pictures. I got one meteor. Um, my camera was looking at a fairly wide piece of sky, but meteors can happen over the entire sky. That's why they're perfect for seeing with just your eyes, because you're going to see more with your eyes than a camera is going to be able to get looking at a smaller piece of sky. This is why you don't want a telescope. You don't want a pair of binoculars to see meteor showers. Um, the next meteor shower that's coming up that I recommend staying up for is the Geminid meteor shower. And the great thing is you don't have to stay up late for this one. Notice what time. The peak is usually around December 13th every year, but you can see meteors leading up to that date and following that date. So the 11th, 12th, 13th, 14th, 15th, right in there. The peak is around the 13th, but you can look on either side of that date, especially if it happens to be cloudy, which it's December, it's usually cloudy. So look at that around 9 p.m. Go outside, base east, look up, and you'll see quick streaks of light in the sky. Those are meteors. Those are little bits of pieces of a comet. The Earth runs into the trail of debris left by a comet in the solar system, and we run into that stuff reliably at the same point in our orbit every single year. And so meteor showers are a lot of fun. There's only a handful that are worthy of really staying up for. If you really get into meteor showers, you can get into the lesser ones, but the Geminids around December 13th is really good. Where we get that name from is all the meteors seem to radiate outward from the constellation Gemini. If you trace all the lines back, they seem to center on Gemini. Oh, by the way, this is an old drawing. Jupiter will not be there for that one. This is I love this drawing, but this was for a specific date a few years ago. But this was the best one I could find. So ignore where it says Jupiter there. The quadrantids um, happen around January 3rd, and you want to go outside, face north, and look up, and you can start going out prior to midnight for this one as well. And the quadrantids are named for a constellation that nobody uses anymore. They used to draw in this part of the sky, some folks used to draw a navigation tool called a quadrant. And so that's where the quadrantid meteor shower name comes from. The name stuck, but nobody uses that constellation anymore. I mean, you can, no harm, but that's where that constellation came from. So this is to the north. And then around August 12th every year, 11th or 12th, we have the Perseids, and those are named for the constellation Perseus. So you go outside, you face east, you look up. The best time to see this meteor shower is after midnight. You need to get up early in order to see this one. So we're talking 1 o'clock, 2 o'clock, 3 o'clock in the morning in order to see this one. That's the best time to do it. But you'll be rewarded by seeing several meteors per hour, even under light polluted skies. The farther out you go away from city lights, the more meteors you're going to see. And again, back to that light pollution map, we've come for full circle. This is where that light pollution map can be really handy. People ask me all the time, where should I go to see meteors? And the answer usually is, if you want to see a lot of them, don't go anywhere in the suburbs or in the city. You need to get out where it's dark. But the other thing that can interfere with seeing them is the moon. You always have to consider the phase of the moon, because that can also wash out some of the meteors. And I think this is my last part. Nope, sorry, second to last. You've probably seen this and just had no idea what it was. This is a time-lapse photo that my husband took on May, it was either 30th or 31st. This is the International Space Station, and this is from our backyard in Aurora. And this was a time-lapse photo, so held the shutter open on the camera, and this is about a 20-second long exposure. So you'll slowly see this thing moving across the sky. It will look like an unblinking airplane. Again, you've probably seen it if you weren't out there directly looking for it, but you probably thought, oh, that's an airplane. But it is an unblinking airplane. There's no blinking lights on it. You can go to spotthestation.nasa.gov, and you can put in your location. You can go to the menu where it says sighting opportunities, and you can go to the location or someplace close to where you are, and you can see when the space station will be visible. And I checked. There are no sightings in this area between October 9th and October 20th. What that means is all the opportunities when the space station is passing overhead is usually, or it could be in the daytime when you can't see it, or it might be in the middle of the night when it's just not being lit up by the sun. So the next one that's visible is on Tuesday, October 20th at 6:48 in the morning. And so if you get closer to that date, go back to Spot the Station, put in your location, and you'll get more sighting opportunities. They usually come in about 2-week chunks or so. So you'll get a few weeks of being able to see it, and then maybe a week or two of not being able to see it, and then you'll see it. And then if it was visible in the early evening just after sunset, there'll be a period of time when it's not visible. Then it's visible in the morning right before sunrise. All right, so that's the best time to be able to see it. Finally, people ask me all the time, when and where can I see an aurora? The town is named for a phenomenon in the sky. Aurora, the city of lights, right? I believe that came from, we were one of the first street light electrified cities, if I'm not mistaken. But this refers to this phenomenon that material from the sun interacts with the Earth's magnetic field, and that causes interactions with our air, and that causes the air to glow. And so that's what we call an aurora, or the northern lights. Okay. And so there is a website called spaceweather.com, and I recommend going there because they have an aurora probability map that is updated all the time. And you can go to see where on that probability map you're more likely to see an aurora. This one was from September 22nd, but this one was from just a few days ago. And notice the probability can fluctuate. And also, I need to remind everybody, it is probability, not this is what the aurora is going to look like. It means the brighter the color on the map, the more likely it is that you'll actually see an aurora. But just because you see it on the map doesn't mean you'll actually see it. So also notice how far north this aurora is visible. We don't get to see them too often in our area. And the reason for that is you need a really active sun in order to have it be seen farther south. So if you want to see an aurora, you have to usually travel. and that means Alaska, northern Canada. Those are the best places to see it. In the United States, you'll see them a little more often than here in northern Michigan, Upper Peninsula, northern Wisconsin, northern Minnesota. Those are good places to go to. So if you happen to be up there, you can check the aurora probability map. If it's green, it means maybe you got a 50-50 shot of seeing it. If it's yellow or red, you have a much higher probability of seeing an aurora. Right? So spaceweather.com is where you'll want to go to check that aurora probability map. Right? And auroras have been called the most amazing and disappointing sky phenomenon you will ever see with just your eyes. You will not see them look like this. They will not look like this to your eyes. This is where pictures really have done auroras badly because all the very fancy colors, your eyes are not sensitive to those colors in the dark. And so you will see kind of a whitish grayish color. You'll see kind of a greenish tint. You might see red, but that's about it. These purples, pinks, yellows, all that, you won't see them. What you will see is structure. You'll see change. You'll see movement. You'll see all of that. It'll look like waving curtains or moving spokes or all that kind of stuff. You won't see vibrant color for the most part. Um, One exception, you can see bright red auroras, and that's the one that I saw from our area about 20 years ago. And so I just want to make sure everybody understands, don't expect this and what's in the picture. If you know what to expect, that makes them so much more interesting because you can enjoy what you are seeing instead of being disappointed by what you can't see, right? All right, last thing is I mentioned some useful tools. So stellarium.org is where I showed you that online sky map. Sky Safari is the app that I personally use on my phone for pointing at the sky and finding things. Starry Night is what I use on my computer at work along with Stellarium. So that's another desktop planetarium program. Spaceweather.com is where I mentioned you can go to see what the aurora forecast might be. Earthsky.org is a great resource. They give you something useful, a little map to look at every single night of the week. Just something simple, like a bright star in this direction, or a planet in this direction, or the moon is next to something. And so that's where you can go to get those in their tonight section. You can see that. AMSmeteors.org is the American Meteor Society. That's where you can go for a meteor shower calendar. And if you want to get a sense of what the moon phase is going to be, is it going to interfere? How many meteors per hour to expect under a really dark sky? All right. If you are just starting out and you go, man, I want to do more than just my eyes, consider a pair of binoculars. Get to know the sky first before you really dive into a telescope. And then there's a book that I'm hoping the library has. If not, I know they can get it for you, called 365 Starry Nights by Chet Ramo. It came out in 1982. And it is still an incredibly useful book because it gives you, again, something to look for every single night of the year. If your sky happens to be clear. And so it starts with Orion on January 1st, the beginning part of the book, takes you through a whole year's worth of stuff to see in the sky. So that is useful stuff. So anyway, so I see we've got a question. The difference between a blue moon and a lunar eclipse. Probably will hear the term blue moon over the next couple weeks, and that is because on Halloween we have a full moon. And this full moon happens to be, according to one definition, a blue moon. And what a blue moon is there is a definition of blue moon that it's the second full moon to happen in the same calendar month. It really doesn't mean anything astronomically. It just means we had a full moon on October 1st, and the cycle of moon phases happens enough that a full cycle can happen, and it's still the same calendar month at the other end. We don't always have a full moon on Halloween. Actually, it happens fairly rarely. The last one was in 2001. And so we have all those depictions of, witches flying on their brooms against a full moon in the sky, but we hardly ever get a full moon actually on Halloween. So this is a full moon on Halloween, where it happened that we had a full moon on October 1st at the beginning of the month. And so our calendar month just happened to last long enough that we get it coming around again. So that's a blue moon. It does not refer to the color. The moon is going to be a light gray or a whitish color. A blood moon. What is a blood moon? So a blood moon is it's a term that actually came about not from astronomy, but from people who were talking about apocalyptic kind of views, but we've sort of co-opted it in sort of everyday speak, and so that refers to a lunar eclipse. And that's when you see the moon kind of that reddish or grayish color. So that is a blood moon, but I had never heard that term until maybe 10, 15 years ago is when it really started becoming popular. So that that refers to a lunar eclipse for the most part. By the way, one thing, I completely forgot to show you one quick thing on Stellarium. So hang on, I want to show you one thing. So give me just a second. I want to point out one thing. I promised to show you moon phases and how you can use Stellarium to see them. So I'm going to go back in time. Hang on. This is the great part about this resource, that we can go forward and backward in time. There we go. And I'm going to go forward by date. So you'll be able to see coming up. There we go. So there's the moon right here. And then if I go step forward by date, you can see it has moved. It's gotten a little bit more lit up, meaning the side that faces us is a little bit more lit up. This is a crescent. And you can click on it, and it will show you some information about the moon, what time it rises, what time it sets, and all that stuff. And then if we go forward again by a day, again, you can see it move. And then as we go forward, we get to Halloween, and this is full moon. So the moon rises when the sun sets. So I just wanted to point that out, that you can use this to see when the moon is going to be visible in the sky. Again, to either help you find the moon if you want to see it, or to help you stay away from it if you want to plan an observing night that has a dark sky. So, all right. Any last questions before we end for tonight? I think I got all the questions in the chat. I'm just checking. All right, there we go. Yep.
Yeah, well, I wanted to thank you so much, Michelle, for coming and talking about astronomy that we can see by ourselves. I think that especially because of COVID and all of the changes that we've had in people's schedules and things like that, I think there's a lot of people who are looking for new hobbies to try or new things to keep them entertained. So,
Absolutely. Absolutely. We have seen some of our I have a favorite telescope vendor, um, not one of the giant, humongous, big online retailers. Um, but I checked my two favorite telescope vendors. They're all out of telescopes. Telescopes, bicycles. No, they don't sell bicycles, but telescopes have been selling out. Bicycles have been selling out. Kayaks have been selling out. Anything involving stuff that you can do by yourself, workout equipment for one person, has been selling out, dumbbells, all that stuff. And it's all because we're all looking for things that we can keep ourselves entertained with and do. We can do online programs like this, but sometimes we just want to get away from the screens and actually go outside. So yeah, we absolutely have noted that people want to get out and commune with the sky and have a new hobby. So yeah, we don't mind. We're closed to the public, but we definitely still have people wanting to know all this stuff. So yeah.
mm-hmm. Yeah, well, thank you so much for coming and talking to us. This video that I did record of this program is going to be on the Aurora Public Library District's YouTube page for 30 days following today. So if there's anything that you want to go back to, that you didn't get to write down or you want to hear again, it will be on our YouTube page and our Facebook page for the next 30 days. So thank you so much, Michelle. This was great.
Thank you.
I'm going to go ahead.